complete for today. This is Unit 1, Lesson 7. So you can either go to the Science2 homepage and look under assignments, or just go to the homepage and scroll down to the weekly calendar. This is task. You're looking for tasks for U1L7, and that's what we're going to get through today. The main thing is to hear from our first two presentation groups, which is going to be The Sun by Abby and Sloan, and then The Inner Planets, Mercury and Venus by Nathan and Summer. And I'll talk us through a little bit of expectations around how presentation is going to work and what to do. But first, I wanted to just briefly review the homework. You had to do a little reflection quiz on Hewitt, chapter 5.1 through 5.4. Did anyone need help on that or have any questions about that? All right, looks like we're feeling good. Otherwise, you just had to make sure that you post your presentation or link to it to the discussion board. I am seeing 6 posts so far, so we just need to hear from one more group. So you guys are on it, much better than my other section. Okay. As a quick do now, I'm going to have us reflect on that Google form I had you fill out last week that was titled Talking About Gravity. It's where you had 2 people chatting with each other. You had Ben, who was saying that we experience gravity here on Earth where there's atmosphere, and when you see an astronaut in space, there's no atmosphere and they're floating around. There's no gravity. So gravity needs an atmosphere to exist. And Kelly, who says, no, like gravity can exist where there's no atmosphere. Gravity does not need an atmosphere. So I've got the numbers on the tasks to complete list. 2 of you selected Ben, 12 of you selected Kelly. So we're definitely shifting towards one type of thinking. I'm going to throw you into breakout groups for 3 minutes. And I want you to be honest, say who you chose and your reasoning, right? What was it? How do you think of and perceive gravity? Or what's your understanding? What have you learned in the past that made you select who you did? Again, we'll come back together in 3 minutes. Go for it. All right, so Nathan, be honest, who did you choose?
I chose Kelly.
What was your reasoning or your understanding that made you agree with her?
I'm going to use the example from our reading homework because it makes it also work in that no matter how far you are from Earth, for example, its gravity is still in effect. It may not be as much, but it's still there. So Kelly's right because it's still there. You may not be as affected by it, but it is still there. It is still happening.
Yep. Yeah, where things get kind of weird is our perception of it. That's what you're getting at. Mm-hmm. Bianca, who did you pick, Ben or Kelly?
I also picked Kelly because I was pretty sure you just need 2 masses and like attraction, which is there. So
yeah, very good. You're kind of getting more at the mathematical equation what Newton was getting at, right? This sort of mass. You have mass and distance, and that's pretty much all it comes down to. Sloan, be honest. Who did you choose?
I chose the boy, but then I changed my mind after I was talking to my partner. So.
Yeah. No, I mean, that's, again, it's a very common thing. I was actually surprised at how normally when I've done this, the class has been usually pretty much evenly divided. But I mean, you could say that Ben has a pretty decent argument because when you see astronauts up in space, right, they have left the surface of Earth, they've left our atmosphere. What do you notice about astronauts when they're in their space shuttle? What are they doing?
Floating.
Yeah, they're floating around. Everything has to be tied down. They have to exercise to keep their hearts strong, and to do that, they have to like tie themselves down onto the treadmill. It's kind of weird, and so yeah, it's you can see how Ben's thinking like you need atmosphere for gravity, and there's clearly no gravity. But Nathan made a good point in the very beginning that it's not actually that there's no gravity. An astronaut's experiencing pretty much as much gravity as you are on the surface of the planet. It's just that they're in free fall around our planet. It's their perception of it, right? They're falling with their spaceship, so they appear to be weightless, even though they aren't. You can have the same experience in an airplane that goes into a dive. If anyone's ever heard of the vomit comets, that's how they train astronauts. Just you're limited in time. You can only do that for 2 minutes before you might hit the ground. So in space, you can do it continuously. But so this is just a little preview of orbit and gravity stuff that we're going to get into in a lot more detail, and we'll continue to work our way through chapter 5 while also doing a lot of the solar system stuff. So any other questions or comments on that? All right, and we are going to get going with our presentations. Sloan and Abby, you feeling ready? Yeah? Okay, so first though, What are my expectations for everyone else who's listening to your presentation? Here's how this is going to work. It's on the tasks to complete list as well. You need to take notes, and you need to submit a photo of these notes as an assignment. So if you look at task to complete number 3, presentation listener expectations, you need to take out a notebook or a piece of paper, something to write on. You should be doing that right now. You're going to need the title of the presentation. Our first one is going to be The Sun. And the presenter names, our first presenters are Abby and Sloan. You need to take notes as they're giving their presentation. I expect at least a half a page of notes, at least. You can take more if you want to. Once you're done, you're going to take a photo of that and upload it to the appropriate assignment. You can see under step number 4, I've got topic number 1, the sun notes. So upload your photo to this first presentation of your notes there. And then topic number 2, when we have our second presentation, take a photo of the notes you take on that and submit it to that assignment. These are, I think, 5-point participation grades. So be ready to do that. Questions on how that's going to work? All right. As you're taking notes too, I encourage you to write down any questions, or if something makes you think of some other connection or something worth sharing, it's always a good thing to do. Abby and Sloan, how do you want to do this? Do you want me to pull up your presentation and kind of go through it as you give me directions, or does one of you want to share your screen and run the presentation?
I can share my screen and run it if that's okay. Yeah.
All right. What I'm going to do is make you a co-host, and then you should have screen sharing capability. All right. Okay, and I guess start us off whenever you're ready.
Okay, can you all see this and you can hear me and everything?
Coming through clear on my end.
Let me find a space where I can put you all so I can actually read this.
You can also, like, if you're getting all those tabs on the top, there's a way to shrink it down.
Yeah,
you can see there's different view options.
I might just do that. Okay, can I start?
Yeah, whenever you're ready. If someone's feeling ready too.
Sloan, are you ready?
Yeah.
Okay. Can you actually give me 1 second? My computer's low battery. Just.
Yeah, no problem. Yeah, we don't want it to die in the middle of the presentation. Trust me, I've had that happen during a lesson. No fun.
Okay, I'm back. So this is the sun. Hi everyone. I'm Abby, and Sloan and I will be presenting the sun. Okay, so first of all, we're going to talk about features of the sun. So the first feature of the sun is the mass. And so talking about the sun's mass, to put it into perspective, we're talking about 1 trillion quadrillion tons, which is a lot of mass. Another feature of the sun that we are going to talk about is thermonuclear fusion. And thermonuclear fusion is the conversion of hydrogen into helium atoms. So that is 4 hydrogen atoms becoming 1 helium atom. And this also produces like radiant energy. I'll get more into radiant energy in a second. And the sun, again, to put it in perspective, contains 99.86% of the total solar system's mass. So now getting back to radiant energy. Radiant energy is electromagnetic waves given off by the sun. And these waves are visible to the human eye. So talking about sunlight and that kind of stuff too. And also within these electromagnetic waves, we talk about photons. And photons are used in solar panels. That's one of our uses for them. And also talking about plants. Okay, solar energy. So solar energy is generated deep within the core of the sun. And the core's temperature of the sun is about 15 million kelvins, which is really hot, and 150 times denser than water. The solar core takes up 10% of the total volume of the sun. And in comparison to Earth, it's about 340 times billion times Earth's atmospheric pressure. So one of the main features of the sun is plasma, and plasma has ionized hydrogen and helium atoms, and they're stored in the plasma. And the plasma is one of the surface layers of the sun, and it's part of the sun that glows, part that we can actually see. And the plasma also contains a magnetic field, which is called the heliospheric current sheet. And this is in charge of the orbit of the planets, and the magnetic field also has other uses that I'll be going over in a second. So the photosphere is another feature of the sun, and its direct translation is sphere of light. So it generates light, but it's not very hot in comparison to other parts of the sun. And its cool or colder parts or dark spots are called sunspots. And the photosphere, again, has a magnetic field around it similar to the plasma. And these large spots are moving. The sunspots are constantly moving because the sun's electrical current and energy is always constantly flowing. So those large spots can actually move. So more in depth about sunspots and solar flares. Sunspots appear as darker because they are colder than other parts of the sun. And they form on parts of the sun where the magnetic field is especially strong. So it's almost like a buildup, like a visual buildup. And these sunspots are so strong that they actually withhold heat from the sun's surface. Now transitioning into solar flares. Solar flares occur when the sunspots are constantly moving. So after a sunspot has moved from its original place, there's a giant release of energy which has been withheld by the sunspot. And with this giant release of energy, there's a lot of radiation. So this radiation can flow into space, or it can even come towards the planets, or especially Earth. That radiation can make our radiation on Earth weird and different. Another feature is the chromosphere. Similar to the photosphere, it actually surrounds it. So it's around, and the direct translation of chromosphere is sphere of color. And this sphere of color can be seen during an eclipse. So that's the main thing that we see when an eclipse occurs. And it is hotter than the photosphere. And it gives off a pink color. And then also, if you look at the pictures on the left, you see like a red sun and a violet sun. So the red sun, when looked at through special tools, is showing the chromospheric network. So what the sun looks like from the chromosphere, just looking at the chromosphere. And then if you're looking at the violet sun, you're looking at ionized calcium in the sun.
Okay, so the corona is the outermost region of the sun's atmosphere. It's very, very hot. And can you keep going, Abby? Okay, yeah. And then, so it's so hot that there's an unknown temperature. And it's not very dense, and the solar wind comes from inside of the corona. And then, so solar wind is a stream of particles released from the corona, and it can reach up to 750 kilometers per second, which is pretty fast. And so solar winds were first kind of talked about and discussed by the British astronomer named Richard C. Carrington. Okay, so age and later stages of the sun. The lifespan of the sun is expected to go on for around 4.5 to 5.5 billion more years, which is good. The sun has not really changed its appearance since its creation at the beginning of the solar system. Kind of stayed the same. So the solar cycle is an 11-year change in the sun's activity. And in that 11-year cycle, the magnetic field component also flips. Satellites. A satellite is a moon, planet, or machine that orbits a planet or star. Some people may be confused like me. I thought it was just man-made stuff, but it's anything that's in orbit. There are natural satellites and artificial satellites, which I just said, and there are thousands of satellites orbiting Earth. So Surface of the Sun, as you've never seen it, is a video we found, and it's really interesting to watch. So, yeah.
Can you all hear this?
Yep.
The sun has shed light on our home for over 4 billion years. It will continue to do so for another 4. It is massive, almost beyond comprehension. Constant, yet ever changing. Born from a swirling cloud of dust and gas, it is a giant fusion engine that drives the solar system. It seethes and boils like a living thing. Loops of plasma rise up so large they would dwarf Earth. Explosions flash on its surface. And yet the sun also gives us warmth and life and beauty.
Nice. That it?
There's a works cited at the end, but you don't need to see that.
Yeah, no, we're good. All right, so everyone unmute yourselves. A little short round of applause.
Yeah.
All over the world. Nicely done. Okay, any questions about the sun? Any mystery that's been on your mind that you want to ask these two well-researched presenters?
Oh yeah. So during that video and like that planet that floated around, was that Mercury? Okay.
Yes.
Yeah, in the video, there's probably the passage of either Mercury or Venus. Yeah.
And that's like a time lapse, right?
Yes.
Okay, good. That's what I thought.
Yeah, the footage was cool. I assume you're looking through filters and it's probably a little bit of artificial coloring, but otherwise, yeah, I mean, all that crazy stuff, I mean, it looks fake. It looks like it's raining and stuff, but as far as I know, that's footage they've captured.
Yeah, that was from NASA's like live footage that have been like cut together to be shorter.
Yeah, and it's just crazy. You see these bursts, and then I've seen videos where it's like, here's how big Earth would be, and it's like nothing. It's mind-boggling to think. So.
Oh yeah, isn't there also like isn't there like a massive? There's like two classifications of like things coming out, and then one of them is like really big, and like if you were to get one of those, it would like destroy atmosphere.
Yeah, it's essentially these, the solar flares, or I think they're called mass ejections that, could either like knock out all electronic devices on our planet, or yes, to like wipe like all the gas away. You had a good diagram there too of the electromagnetic waves, which contribute a lot to why we see northern lights on the northern and southern poles too. It gets pretty technical learning about that, but it's kind of a cool explanation for what's going on there. Really cool diagram too of the life cycle of the sun. I was wondering, do you know where we are in that? Like it's an 11-year cycle.
I think we just shifted to whatever like the two sides are. That kind of research,
Yeah, I probably did too.
yeah, is that kind of research is really hard because there's just not a lot of information out there that's easily accessible. But I'm pretty sure we just like experienced a shift in our magnetic thing with the sun.
Yep. Yeah, I think in December of 2019, there was technically, we restarted a new cycle. So the sun is technically in like a calmer phase right now, I think. Like there's not as many sunspots and stuff. But I don't know much about it either. But it's pretty interesting. So, all right, any other questions? So Abby and Sloan, just make sure that you have filled out the survey for questions, for test questions. Again, I only need one of you to do that. I just need one set from the group. Okay, we'll move on to the next one, which is Inner Planets, Mercury and Venus by Nathan and Summer. Nathan and Summer, are you feeling ready?
I guess as ready as we can be.
Okay. Who wants to, do you want me to open your presentation to go through it, or does one of you want to do it?
I guess I could.
Okay, I will make you a co-host so you can share. Everyone else, again, you need to be using the same notebook or same piece of paper. This time we are hearing about inner planets, Mercury and Venus, with Summer and Nathan. Okay, just made you co-host.
Okay, give me 1 second and I'll get it up.
Yep, no problem, take your time. Helps sometimes to preload the videos too, like if you know you're gonna show a video, you can open it and pause it.
Yep.
And not all waiting, so. Yeah, the other depressing thing I always hear about with the sun is that, Sloan, you mentioned that it's got another like 4.5 to 5.5 billion years. But does anyone know, is the sun going to change at all in that time as it ages?
I thought, doesn't it turn into like a supernova?
It's on its way to a supernova, but yeah, I think one of the phases on its way to that is it becomes a red giant, where it's going to swell in size. Does anyone know what's going to happen to Earth at that point?
Earth is going to get consumed by it.
It'll be completely destroyed. So yeah, nothing will last forever, and if we want to survive as a species, we're going to have to get off this rock. So anyway, kind of interesting way to think about things, but long, unimaginable amount of time till then. So anyway, okay. Yeah, I think as long as Nathan, you, and Summer are ready, then go for it.
Okay, this is the inner planets of Mercury and Venus. Wow. There we go.
Okay, so what are the inner planets? I didn't put this in the slide because it's kind of dumb, but it turns out that they aren't mini planets inside of the other planets, as I thought. Anyways, the inner planets are the planets that are closest to the sun. They include Mercury, Venus, Earth, and Mars. Another name for them is terrestrial planets. They are mostly made up of rocks and silicate metals and have mostly like hard surfaces. They either have 1 to 2 moons or none at all. They spin a lot slower than the outer planets. They have shorter orbits around the sun, and they don't have any rings. Mercury is the closest planet to the sun, and it is the smallest planet, only 1.4 times bigger than the moon. 1 year on Mercury is 88 days on Earth. 1 day on Mercury is 59 Earth days. And if Mercury has no moons, it has high temperatures of 430 degrees Celsius and low temperatures of negative 180 degrees Celsius.
Kind of looks like the moon, doesn't it? Does that strike anyone as interesting that a day is almost as long as a year?
Yeah.
And Summer, I think you skipped a slide there. You jumped to slide 3. Yeah, there we go. Right. I think we skipped slide 2.
Mercury does not have an atmosphere, but instead a thin exosphere. It's made up of oxygen, sodium, hydrogen, helium, and potassium. Mercury's exosphere was made from asteroids and solar winds that hit its surface. And then we have like a diagram.
Yeah, and adding on to this, as the diagram shows, that the atmosphere is 42% oxygen and 29% sodium, with hydrogen making up the other 22%, which shows that potassium part and the helium part are very small in that 7% of the atmosphere. And it did originally have a fuller atmosphere, but the solar flares destroyed it, making the exosphere.
And so if an idiot was going to try to light a cigarette on the surface of that planet, anyone know what would happen? With that much hydrogen and oxygen in the atmosphere?
I'm assuming it would go boom.
You would explode.
Okay, so humans on Mercury. There are ice caps at the poles, but they're too cold to inhabit. There are still natural disasters on the planet, such as collisions and compressive earthquakes, and the sky would appear black.
Yeah, and adding on to this, you would have no form or possibility of seeing anything because the sky would appear black. There would not be much light, and that's due to the atmosphere. The chemicals in it distort the light, and there have been theories onto how to inhabit, on the possibility of inhabiting Mercury, and you'd have to sit in between the equator and the ice caps to try and get something that's moderate to Earth, but even though that's not possible, that's the closest you could get.
Life on Mercury. There's evidence of previous life on Mercury. Reasoning for Mercury's surface structure is accredited to volatiles, which contains water. This evidence of previous water on the planet and the ice caps of the planet have led scientists to believe life could have once been possible on Mercury.
In this diagram shows the different ice caps there are on Mercury. There's the very North Pole, which has the largest, but those other red spots and orange spots are the other ice patches. And Venus. Venus is the second closest planet to the sun and is only slightly smaller than Earth, with a radius of 3,760 miles, putting it as Earth's closestly similar planet in size. And one Venus year is 225 days on Earth, with a Venus day being 243 days on Earth, which means a day on Venus is longer than a year on Venus, which is interesting to think about. And the average temperature on Venus is 471 degrees Celsius, which is hot enough to melt lead. The atmosphere of Venus is mainly carbon dioxide with 96%, and the clouds are all over the atmosphere of sulfuric acid, and the highest clouds move at a speed of 224 miles per hour, making very strong, almost hurricane-like conditions. Interestingly enough, though, there is a layer in the atmosphere that has climate similar to that of the surface of Earth. And due to this very, very dense atmosphere, the pressure on the surface is as if you're a mile underground in water. Well, mile deep in water, sorry.
Wow.
Humans on Venus. Human life on Venus is absolutely impossible to sustain due to the harsh conditions, with the air being unbreathable. There's sulfuric rain. You'd be crushed by the atmosphere's pressure, and as I said earlier, the surface temperature is hot enough to melt lead. This image is from a Russian probe that was landed in 1985 on the surface of Venus, but it only lasted for a few hours before it was destroyed by the harsh conditions of Venus. And the life on Venus. Recently, as early as 3 weeks ago, some of the more recent reports have come out of life being found in in Venus's atmosphere that is similar in the zone that is similar to Earth's temperature. And this life possibility is called phosphine, which is phosphorus hydride. And phosphine is something that's found in Earth from different animals and things like animal waste or human industrial things. And this video is just a breakdown of what phosphine is.
Phosphine is the best known hydride of phosphorus.
Is there a way to turn up the audio a bit?
Possibly.
It is usually obtained by boiling.
I think we're hearing it through your computer speakers.
Yep. Give me 1 second.
Yeah, pretty fascinating. My understanding was it's one of these chemicals that they're pretty sure doesn't occur like naturally. Like it has to be formed by activity of life or something like that.
Yes, it was known to be formed by these other materials that is created by life, thus creating the feces part from other animals. Shows that something had to make this. Scientists believe it may be life. It could be some other natural phenomenon that they're not sure of, but at this point, that is their best belief. And that was just that short clip of that video breaking down generally what it is. And this is a contrast of some of the other pictures shown earlier of how different these planets can look. So on the left, you have Mercury compared to what it was earlier. And just instead of this dark gray that looks like the moon, you have all of this light in it. And these patches in it are the different materials that are stuck on the surface. And they believe some of these more yellow spots could be patches of ice that are underneath the surface that have mixed with so many other things that distorts the color. And here, Venus, it almost has the appearance of like Mars, which is really interesting. And this is captured from NASA's daily photos of the different planets that they publish. And that's the end.
Awesome. All right, again, let's have everyone unmute yourselves. Round of applause. Very interesting. Any questions about Mercury or Venus? Anything you've been dying to know?
I had a question about what the ice caps are made out of. Are they made from water or carbon dioxide or?
The ice caps were made from water that was previously on the planet, but due to over time the sun getting hotter, kind of like the gas giants, it solidified sooner, and due to all the solar flares that destroyed the atmosphere, evaporating all of the water, and there's a weird chemical reaction within the planets where it's an endless loop in the planets of the sun destroyed the atmosphere, which heated the planet and evaporated things, which continued to heat the planet. So it's an endless cycle of just the planet warming. So there was once water, but it's all just stuck now. That's evaporated. And the ice caps are what's remained underneath the surface.
Nice. Yeah, my understanding too, I'm not entirely sure, but we often think, oh, they're so close to the sun. How could water or how could ice even exist? But as Nathan said, you have to have an atmosphere to really get like a significant amount of heat. Also, the water probably has a lot of stuff dissolved in it, which messes around with boiling point and things like that. And pressure can make a big difference too, especially Venus-wise. If the pressure is so high, you could actually have water being retained, or at least in the atmosphere. It's kind of interesting. But yeah, that struck me too, Harmony, was like there's ice on the planet that's technically closest to the sun, but kind of gets to that idea of how this exosphere, as Nathan's been saying, has been preserving it. Plus, as Summer was highlighting, the contents of the atmosphere, right, is oxygen, sodium, hydrogen. None of those gases are very good at retaining heat, even in abundant amounts. Whereas, did anyone catch what gas was the most abundant on the surface of Venus?
Is it carbon dioxide?
And what's carbon dioxide doing to planet Earth as we pump our atmosphere full of CO2?
Making it hotter, like.
Yep. Yeah, global warming. CO2 is very good at capturing heat. So that's another reason why, even though Venus isn't the closest, it is actually the hottest planet because it has this gaseous heat capturing atmosphere.
Yeah, and with Venus, the scientists do believe it was at one point similar to what Earth is today, but it changed to what it is now when Earth started for what it is today. So basically, at the end of Venus's lifetime, Earth started its, which is what caused. So scientists have actually used that as a belief on what could happen to Earth.
Yeah, I get it. Yeah, especially as our sun expands or heats up. Yeah, it's kind of interesting to think about. Hmm. Yeah, and the life stuff I think is interesting. I encourage everyone, you should go look at recent articles. We did a good summary about phosphine, which again, it doesn't seem that exciting. It's like whoop-de-doo, there's a weird chemical in the atmosphere, but it is pretty mind-boggling. If they can't figure out where it's coming from, then it's probably some form of life that might be doing it. And bacteria doesn't sound exciting, but again, it's the kind of thing that if we can find it, and if it has DNA or doesn't have DNA, there's so much you can learn from these kinds of things. So,
And just a funny little fact about the findings of life is for the telescope that they used to take the images that they discovered it with, the images were actually taken in 2017, but they weren't analyzed until late last year. So they've
Yeah.
just been sitting around.
That's interesting. Yeah, it makes you wonder what else they're sitting on or just haven't gotten to yet, So, all right, any other questions or comments? All right. Nathan and Summer, make sure to submit questions based on your presentation to that Google form. Again, I only just need one of you to fill that out for the group. Everyone else, make sure you have your notes and you can upload photos. Again, that is not due until the next time we meet, though, further down. So thanks a lot for those first two groups. What I want to do now is just quickly review the Hewitt Chapter 5 reading that you did and explore gravity a little bit more, though I think we're feeling pretty comfortable about that. I'm going to share my screen here and just walk us through some brief slides summarizing that, and then we'll do kind of a little activity. All right, and I'll have people just kind of jump in here, so don't be afraid to shout out. But the chapter starts off talking about Newton. What's the legend? I have no idea if this is true or not, but what hit Newton in the head, supposedly?
An apple.
Right? Fell towards our planet, yes. And that got him thinking, okay, gravity's pulling things downwards. And so he was like, well, wait, if that's happening to an apple, why doesn't that happen to the moon, which is a much larger solid object that is also technically within Earth's grasp of gravity? So he came up with that question, right? Why doesn't the moon fall towards Earth like an apple does? And again, so what's the secret? What's the main point of section 5.2? Specifically, who can put that in more friendly terms?
It's the moon falling around the Earth like circularly.
Yeah, very well said. Exactly. That's what you need to start thinking of orbit as actually falling, because that's exactly what's happening. Very good. The moon and anything that's orbiting our planet, whether that's like a TV satellite or whatever, it's just moving sideways. It's moving parallel to the surface of our planet at a speed that is just enough that it will never hit the surface of our planet. So it is technically falling towards Earth, right? Gravity is pulling it towards the center of our planet, but it's moving sideways with so much speed that it's never going to actually hit the planet. Now, this is something we'll get at later. This picture actually isn't that accurate. Are orbits actually perfectly circular? Anyone know? Or are they a little more elliptical? What do you think?
They're more elliptical, right?
Yeah, and we'll get at what's going on with elliptical stuff when we get into more detail. But yeah, and your book has a good diagram of, if the planet were to suddenly disappear, then you would just have the tangential velocity, which would slingshot the moon or anything else out of orbit. And as far as I understand, the moon is slowly, I don't think it's falling towards Earth, right? It's falling away from Earth. Its orbit is decaying. Or no, I guess that's not decaying, it's expanding, right? Where it will actually eventually float away from our planet over a very long period of time. So we are kind of Earth is losing its grip on it. So Newton did a lot of thinking and a lot of experiments around gravitation, and he came up with Newton's law, which we're going to add a variable to. This is not the complete law, but just to keep it simple. F is just gravitational force, which we literally measure in newtons, named the unit after him. And as complicated as this might look, all it's showing you is that mass, gravitational force is directly proportional to mass, right? So that means that the larger, more massive something is, the more gravitational force it can exert on the things around it. And it's inversely proportional to the square of the distances, again, which is just a fancy way of saying that if things are farther apart, they're not going to exert as much gravitational force on each other. Again, so think of it that way. Bigger objects exert more gravity, and things farther apart, they're going to have weaker gravitational force. So that's why technically all of us in this class, even though we're all over the place, you're all exerting gravity on each other, right? Gravity exists between any object that has mass and distance. but we don't feel it. It's so insignificant. But planet Earth itself, which is much larger and has a lot more mass and is pulling us downwards toward it because of that. It has so much mass, we can sense that gravity. But the moon is able to stay at a distance because, again, it's that distance there. So it's technically experiencing a little bit less gravity. Plus, we talked about that tangential velocity, which is actually contributing more. But we can quantify that loss of gravitational force with distance. And that's what's called the inverse square law, which still kind of confuses me. But think of it as just it's weakening by the fraction of the square, right? So the way I think about it is if we've got a source of gravity here at the center, so think of that as our center point there. Let's say you've got one standard distance. I don't know what this is. Let's just say that's think of that as like the one, right? There's an object that's a certain distance from the center. Oops, let me get rid of this. If you have another object that is twice as far away, then it's going to experience 1/4 of the gravitational force. And that's because that's 1/2 squared, right? That's the inverse square. If you had something that was 3 times as far away, then it's going to be experiencing 1/9 the gravitational force, or 1/3 squared. So that's what the inverse square law is getting at, is that the diminishment with distance is, again, just divide by the square of that distance. So we can actually display this with 2 kind of silly activities that we'll do. And I'm going to need cameras on for this. We can play with perspective a bit. First thing I'm going to have you do is just hold up your hands. And what you're going to do now is you're going to bring one, so hold them so that you can see them both, right? Think about crossing your thumbs, right? And keep them in this orientation. But then what you want to do is bring one closer to your face and the other one further away. And then look with one eye. And if you get it just right, it looks kind of funny, but does it look like one hand is a lot smaller than the other? Anyone seeing that? Can you get a yes or a no? Or I guess you can't unmute yourselves because your hands are busy. But if you get it just right, see if you can get it to the point where your distant hand looks like it's 1/4 the size of the closer hand. For me, it's right about there, I'd say. Looks better with the outer eye. And so that, technically, you're using perspective to play with this idea of the inverse square law, right? That if we hold one hand at a halfway point and the other hand technically twice as far away, that the more distant hand looks like it's 1/4 the size. It's kind of hard to do that with hands though. And so the other activity we can do is if you can go find 2 pieces of cash. I know not everyone uses cash or has cash much anymore, but if you can find $2 bills or whatever else, or if you just any 2 pieces of paper that are the same size, you could even go get a toilet roll and just get 2 squares of toilet paper. Go collect that for me and then come back to your computer. So we just need 2 pieces of something you can fold that are the same size.
Do we need these anymore?
Oh, no, we won't really come back to that. So yeah, no, you don't have to do that. Or yeah, you can use it as a tissue, blow your nose into the history of the universe. All right, everyone got money or paper or something that's of equal size? No one went and grabbed $100 bills. I keep waiting for one student to show up, be like, oh, this is all I had. All right, so here's what you're gonna do. This is for size comparison. So one you're gonna leave unfolded, so just leave it as it is. The other one, you're gonna do 2 folds, right? Fold one way and fold the other way, whatever they call the hot dog fold and the hamburger fold or whatever you call it. But point is you're folding it down so that it is 1/4 of the size. So as everyone see here, if you're doing it right, when you compare the 2, right, everyone see how I've got my unfolded dollar, and then clearly my folded dollar is exactly 1/4 the size. So now we're going to use perspective and this idea of an inverse square law to get these to look like they are the same size. So just like with your hands, you're going to hold the folded one closer to you, right? And then hold this one, the unfolded one, farther away and try to find that point where from the look of just one eye, so close one eye, only look through one of your eyes, get it to the point where they look like they're the same size. You could even try to overlap them a bit. To me, it's right about there. Pretty crazy. And so if we were capable of measuring the distance from our eyeball to these objects, what you would find is your unfolded piece of paper is twice as far away from your eye as your folded one. And it still appears the same size because again, it's 1/4 as you're seeing it as 1/4 the size. So again, this kind of it's a flip, it's a reverse version of what we were doing with our hands. So anyway, just kind of a silly way of demonstrating the inverse square law. We will actually be doing a little bit of math and some equation work with that a little bit later. But that's just kind of a fun activity to explore it. So that was it from that first part of chapter 5. Any questions or comments on that? All right, homework is on the bottom of the tasks to complete list. I know it looks like a lot, but let me just walk you through it. The first bullet point is just making sure you're submitting your photos of your notes. So sun notes and inner planet notes. Again, obviously, if you presented that subject, you don't have to submit notes because you were presenting instead of listening. We are now just over 2 weeks in, so I would like to collect some feedback from you. So there's an anonymous feedback survey there. As a little incentive, it is a participation grade. So fill out the survey anonymously, and then on the assignment, just type done into the text box, and you'll get 5 points participation grade for that. Please check your grades. I'm still working on catching up on grading assignments, but as they roll in, if you have any missing work, now's the time to start completing it before our sort of like early check and comments happen on October 5th. And otherwise, just make sure you're ready to present for next class meeting, which is going to be Earth and Mars, topic number 3, and then topic number 4, the outer planets. So make sure you're ready to present on those on Thursday. Questions on the homework? Yeah, Nathan.
You said answer done in the text box. Where should that text box be? Because the assignment's locked till 6:30.
Yeah, once it comes out at 6:30, you should have an option to submit a typed response, and that's all you have to do is just type done. Yep.
Okay.
Yeah, sorry, I timed it so that it'll release at the end of class. So, good question. Any other ones? All right, well, thank you very much then for the groups that presented. Good job. And I will see you all on Thursday. Have a good day.
Thank you.
Thank you.
I'm muted. I just had a quick question.
Mm-hmm.
So I have my notes here. Do I also I did a full page. I hope that's okay.
Oh, that's great.
Do I put it in like the submission box on like I like couldn't find it.
So you'll see there should be an assignment. So if you can either look under assignments or on the tasks to complete list. I have it listed under the homework.
The fun notes?
Yeah, so like some notes, click on that, and then you should see a little button to like upload image or whatever, and then that's what you can airdrop it from your phone or whatever else. So I have been noticing like homework submissions. I haven't seen many from you yet.
I am planning on this weekend. I am going to sit down and do all of my assignments because I have them. I just haven't like turned them in because a lot of the time I didn't realize that I had to. I thought that I just do it, so I'm going to do that this weekend.
Okay, I'm hoping to. We'll probably end classes early a couple times. I'm hoping to do that. I'm going to use that time to kind of gather all the students who have missing work, and that'll be a time to like check in with me, see if I can help, just guide you, walk you through things. But the more you can kind of, you just want to avoid the snowball effect. So like the more you can kind of get done and out of the way. I'm feeling that way with grading. I'm already behind on grading. I'm trying to keep up too. So, but let me know if you need help. I'm happy to just call and like walk you through assignments too, if it's faster to work that way.
Okay, cool.
So cool.
Thank you.
All right, thanks.